Hello everyone, so welcome again to study room. Today we'll be studying about thrust and pressure. So what is thrust? Basically thrust is your perpendicular force acting on an object. So we'll learn more about thrust in this chapter. Okay, so don't get worried about this. And what is your pressure? We'll learn about this also. Pressure is how much force is applied in a given area. So pressure is given by force upon area. What does that mean? That if your pressure is directly proportional to your force. So if your force increases, your pressure also increases, and pressure is inversely proportional to area. What does that mean? That if your area increases, your pressure decreases. So, some brainstorming questions. Why a camel can run in a desert easily? So, have you ever wondered that why a camel can run in a desert easily? It is because they have a wide feet, okay? They have a wide feet which has larger area. Okay, which helps them to balance their weight on loose sand, and wider feet gives a larger surface area. So why are we talking about surface area? Oh, I don't get this, right? Because we know that pressure is dependent on our area. It is inversely proportional to area, right? So as your area increases, your pressure will decrease, right? So why a camel can run faster? Because the pressure is less. Why? Because they have a wider feet. Wider feet means larger area. Larger area means less pressure. Less pressure means that lesser impact, right? So they can run fast. They can run easily in a desert, right? So it is all because of pressure. Okay, because the wider feet gives them larger area and it decreases pressure. Why an army tank weighing more than 1,000 ton rests upon a continuous change? It is again due to pressure, to reduce pressure. Why a truck or a motor bus has much wider tires? Why? To reduce pressure, because wider tires means larger area means lesser pressure. Why cutting tools have sharp edges? To reduce pressure. Correct. So let's move forward. So let's study about thrust and pressure. So thrust is the net force acting in a particular direction on the object, and the force per unit area is called the pressure acting on the object. So thrust is a type of force only, right? It is a perpendicular force. So what does that mean? What is the SI unit of thrust? Again, it is Newton, correct? So illustrations of thrust and pressure. To fix a posture on a bulletin board, we have to press drawing pins with the thumb. We apply force on the surface area of the head of the pin. This force is directed perpendicular to the surface area of the board. This force acts on a smaller area at the tip of the pin. We know that pressure is equals to force upon area. And if we are applying the force on a smaller area is less. What does that mean? That pressure increases, and if pressure increases, then your pin will go inside, right? So To fix the pin, we use force, and we reduce the area to increase the pressure and to fix the pin, right? So that the pin goes in. So this is another illustration. When we stand on loose sand, our feet go deep into the sand. Have you ever seen that, when you are standing on a stand, your feet, they just they just sink in, right? So now if we lie down on the sand, our body will not go that deep in the sand. So when you lie down, then you don't sink in the sand, right? You are on the surface. Why so? Because when we are talking about your feet, so the area of your feet is less, right? Less area means more pressure. How? Because we know that pressure is equals to force upon area. So if your area decreases, pressure increases, right? If area decreases, your pressure will increase, right? If you see, the area is in denominator, correct? So your pressure will increase. That's why your feet, which have lesser area, they have more pressure. That's why they sink in. And if you talk about your whole body, if you lie, so it has a larger area, right? If you have larger area, your pressure will be less. And if your pressure will be less, you won't sink in, right? This is the reason that your feet go deep into the sand, while your body, it does not go deep, it will not go deep, right? So let's have effects. Let's study effects of force of same magnitude. Okay, we're talking about same magnitude. What does that mean? That it has same numerical value. Okay, so let's study this. The effects of force of the same magnitude on different areas are different. Thrust is same in both the cases, standing and lying, but effects are different, just as we saw the case of feet and your body. So thrust, it has different effects in different cases, correct? Therefore, the effect of thrust depends on the area on which it acts. So when it was feet, it was a smaller area, and when it was your body, it was a larger area, right? The effect of thrust on sand is larger while standing than while laying, just as we saw in the previous example, correct? So pressure. What is pressure? We already know pressure is equals to thrust upon area. Thrust is a type of force, right? Thrust is a type of force. Basically, thrust is your perpendicular force. Like when on your feet, a perpendicular force was applied, and when on your body, a perpendicular force is applied. Thrust is a type of force, nothing but a type of force. So pressure is force upon area. You can say this also. And pressure is equals to thrust per unit area. SI unit of pressure is Newton per meter square. How do we get this? We know that pressure is equals to force upon area is equals to thrust upon area. What is the SI unit of force? It is nothing but newtons. And what is the SI unit of area? We know area we measure in meter square. So we get that SI unit of pressure is Newton per meter square. Isn't that easy? So in honor of scientist Blaise Pascal, the SI unit of pressure is called Pascal, denoted by PA. Okay. So basically, 1 unit of pressure is Newton per meter square, which we derived. Just like for force, since our Newton sir gave it, we said that its SI unit is Newton, N, right? Just like that, for pressure, our SI unit is Pascals, PA. We denoted by P under in the honor of the scientist Blaise Pascal. Okay. So let's do this question quickly. So let's try. You need to try first. A block of wood is kept on a tabletop. The mass of the wooden block is 5 kgs and its dimensions are 40 into 20 into 10 centimeters. Find the pressure exerted by the wooden block on the tabletop if it is made to lie on the tabletop with its sides of dimension, this case 1 and this. Okay. So let's do this together. So let's do this. So your mass of wooden block, so its dimensions are given, okay? And we need to find the pressure. We know pressure is force upon area. So we need to calculate the area, right? In both the cases, right? So let's get started. So firstly, your mass of wooden block is So your, just like clearly, right? Mass of wooden block is 5 kgs, correct? And what is your thrust? Thrust is your nothing but your perpendicular force. Thrust is your equal to mg, correct? Thrust is your 5 into 9.8. How much is this? 5, it's a 14, this 49 newtons, right? This is 49.0, 49 newtons. Then you need to calculate the surface area. Okay, so we'll just see how much surface area was this. So we know the dimensions are 40 into 20 into 10. So what will be the surface area? Surface area will be this dimension, right? Surface area is 20 into 10, right? 20 into 10. This will be the surface area. We're not talking about the volume. If we had to take volume, we would have taken all the dimensions. But since we have to take the area, which dimensions are we going to take? The rectangular dimensions, which are 20 into 10, okay? So what is your surface area? It's 20 into 10 and it is equals to, 1 second. Yeah. Surface area is 20 into 10 is equals to how much? It is in centimeters, right? 200 centimeters square. And now you need to convert it into meter square. How much does it come out to be? 0.2 into 0.1 meter square, right? It is equals to 0.02 meters square. And what is your pressure? Your pressure is nothing but force or thrust upon area. Correct. So, how much is your force or thrust? It's 4.9 upon area 0.02 meters square. Right. It is equals to how much? 2450 Newton per meter square, or you can say 2450 pascals. This was for your case A. So, let's now calculate for case B. Okay. So, for case B, your dimensions are 40 into 20 into 10. Right. 40 into 20. For the second case, we have to calculate for 40 into 20. Right. For this cube, for this cuboid, firstly, we took the dimensions 20 into 10 for the A part because it was given, and for the B part, we are taking which surface, where your 40 is your this and this 20, right? We are taking this surface, okay? So, again, we will calculate the area. So, for case B, what will be your area in this case? Again, your area will be 40 centimeter into 20 centimeter, right? So, it is your 0.08 meter square. 800 centimeter square is equals to 0.08 meter square. Again, we will calculate pressure. Pressure is nothing but force or thrust upon area. How much force do we have? Again, a force is 4.9 newtons. 4.9. And how much it is? 0.08. Which comes out to be how much? Just calculate this. It comes out to be 612.5. One second. Yeah. So, it comes out to be 612.5 Newton per meter square. Another unit for pressure, pascals. So, 612.5 pascals. Okay. I hope this is clear. So, pressure and area relation. We know pressure is inversely proportional to area. Why so? Because pressure is equals to force upon area. What does that mean? As your area increases, your pressure decreases. Right? If your area is 50 centimeters square, let us suppose, and your area is 20 centimeters square, which one has more pressure? You tell. Of course, this one has more pressure because it has lesser area. Okay, so smaller area means greater pressure because they are inversely proportional. 1 upon area, right? Greater pressure. And larger area means smaller pressure. Correct? Just like we saw in that camel case, that for camel it has wider feet, so it reduces pressure. Wider feet reduces pressure for camel, right? So the same force acting on a smaller area exerts a larger pressure, right? Smaller area, greater pressure. and a smaller pressure on a larger area, right? Smaller pressure, larger area. This is the reason why a nail has a pointed tip. So why a nail has a pointed tip? Pointed tip has smaller area. Smaller area means greater pressure. Greater pressure means that the nail can go in easily. Knives have sharp edges. Why? Sharp edges means less area. Less area means more pressure. So it is all interrelated. You see, all the things you use in the daily life, they have the application of pressure, correct? And buildings have wide foundations. Buildings have wide foundations to reduce pressure, right? Because if your foundation is wide, so area is more. Your area is more, your pressure is then less. So let's study pressure in fluids. Fluids, what do you understand by fluids? Any liquid, correct? Liquid form, liquid state, right? That is a fluids, like your water is a fluid, your oil is fluid, your what else? Juice is fluid, correct? So any liquid form, right? It is fluid. So let's study pressure in fluids. So it has a new name. We give a new name to pressure in fluids and we'll learn about it, okay? So pressure in fluids. So all liquids and gases are fluids. A solid exerts pressures on a surface due to its weight. Fluids too have weight and exert pressure on the base and walls of the container in which they are enclosed. Pressure exerted in any confined mass of fluid is transmitted undiminished in all directions. So for fluids, there is no fixed direction, right? Because fluid, for example, this is a fluid. So your pressure exerted is confined in any confined masses, undiminished in all directions. Okay, same in all directions. So let's have some brainstorming questions. Have you ever had a swim in a pool and felt lighter? So all of you might have done swimming sometime in your childhood, right? Or maybe you swim right now also, right? So have you ever had a swim when you felt lighter, like you felt very relaxed and light after swimming in a pool? Why so? Have you ever wondered? Or have you ever wondered why a ship made of iron and steel does not sink in seawater? But while the same amount of iron and steel in the form of sheet would sink. So, these things also have a scientific reason behind them. So this is interesting, right? So there was a scientist, have you heard of Archimedes' principle? So have you heard of that story in one English chapter in Archimedes where he started shouting in the bathroom when he just found out this principle, correct? So, this principle has came from that story only. So this person, while taking bath, he just discovered this thing, okay? That what did he discover? That that the force exerted on body was equal to the weight of the fluid displaced. He felt that he felt lighter while swimming in his bathtub. He felt very lighter, and he eventually wondered that why so. And this is how this principle came into picture. So what does what this principle states? Let's study about that, okay? So it states that the upward buoyant force that is exerted on a body immersed in a fluid is equal to the weight of the fluid that the body displaces. Now you people will ask, what is buoyant force? Buoyant force is nothing but the upward force which acts on a body, okay? Buoyant force, perpendicular upward force. So what did he found? So he stated that the upward buoyant force that is exerted on a body immersed in fluid is equal to the weight of the fluid that body displaces. Okay, you must watch this story. Have you ever wondered why a ship made of iron and steel does not sink? Same reason, due to Archimedes' principle. What will happen? What does Archimedes' principle state? That the upward buoyant force is equal to the weight of the fluid displaced. Okay. So now your iron nail sinks because it has more weight than the water it displaces, correct? So here also this Archimedes principle is applied. So let's quickly read and learn about it. So let's watch this video.
Welcome to the Neutral Buoyancy Lab at the Johnson Space Center in Houston. This is the largest indoor pool in the world and contains a full-scale replica of the International Space Station with a support staff and a control center. Come, dive in. Assisted by a team of support staff, our astronauts practice here for their upcoming missions to the ISS.
So let's do one activity with plastic bottle and water. So what did we observe? That initially the bottle floats, but when the bottle is pushed into water, an upward push exerted. Okay. Result, it will be difficult to push deeper, which indicates that water exerts a force on the bottle in the upward direction. The upward force exerted by the water goes on increasing as the bottle is pushed deeper till it is completely immersed. When the bottle is released, it bounces back to the surface. Correct? So again, Archimedes' principle is the reason behind this. Okay. How can you immerse the bottle in the water? If you want to immerse, what does immerse mean? That you want to, push the bottle completely inside the water, right? You want to immerse the bottle in water. So how can you do this? The force due to gravitational attraction of the earth acts on the bottle in the downward direction. So the bottle is pulled downwards, but the water exerts an upward force. We know what is this upward force called? Buoyant force. Okay. Upward force is called buoyant force. Okay. So the water exerts an upward force, buoyant force on the bottle. Thus the bottle is pushed upwards. When the bottle is immersed, the upward force exerted by the water on the bottle is greater than its weight. Therefore, it rises up when released. Okay, so have you ever seen that when you take a container, okay, take a container, put some water in it, take a water bottle, and you just drop it. When you drop it, you'll see that it will float. It will not sink. But when you want to immerse it, you'll push it down, right? You push it down and upward buoyant force is applied on it, right? And therefore, when you release, it rises up. When you release the bottle, it again rises up. Have you ever noticed this thing? Right? You try to push it, you think, you feel that you're applying some force to push it down. Right? Why so? Because there is one upward force acting on it, that is your buoyant force. So how can you immerse the bottle in the water? To keep the bottle completely immersed, the upward force on the bottle due to the water must be balanced. This can be achieved by an externally applied force acting downwards. Right? You want to completely immerse the bottle in the water? You need to apply force and push it down, because there is one upward force which is acting on water, which is trying to pull it up, right? If you will just drop it, if you will just drop the bottle, it will just be rising, okay? It will not go down. But if you want to immerse it completely in the water, you need to apply force. Why do you need to apply force? So that your buoyant force is smaller than your force. When your applied force is greater than the buoyant force, the bottle will completely immerse in the water. Correct? Because there is one upward force which is continuously acting on this container. And what is it called? Buoyant force. Okay? I hope this is clear. This is a very, very important concept. Okay? The force must be at least equal to the difference between upward force and the weight of the bottle. Of course, right? Your force must be greater if you want your bottle to immerse in water, right? Otherwise, it will rise up. And if you release the force, you'll see that the bottle will again rise up. Why so? Because when you release the bottle, only the upward force will be acting on it, which is your buoyant force. So let's study quickly about buoyancy. It is the upward force exerted by water on the bottle. I already told you this, right? It is known as upthrust or buoyant force. So what is your buoyant force? It is your upward force exerted by water on the bottle. And there is one more name given to it, upthrust. Why do we give this name to this force? Because we know that thrust is a kind of force and up means upwards, right? And we know that buoyant force is acting always in the upward direction, right? So of course, this is a logical name. That is your upthrust, correct? Correct. So upthrust is your logical name, okay? Upthrust or buoyant force. So can you give one example of can you give one example on which this force is acting? Yes, I can give, right? In fluids, in water, buoyancy is acting, buoyant force is acting, upthrust is acting, correct? So, why objects float or sink when placed on the surface of the water? Have you all studied about density earlier? Density is equals to mass upon volume. I hope you have learnt about this earlier also. Right. So, the force due to gravitational attraction of the earth on the iron nail pulls it downwards. So this was the result of our previous water experiment, right? Immersing bottle experiment. So there is an upthrust of water on the nail which pushes it upwards, but the downward force acting on the nail is greater than the upthrust. Hence the nail sinks. So in the case of nail, what is happening? That your upthrust, upper force is less. And the force of nail has a very heavy mass, right? So its downward force is greater. That's why what happens? The nail sinks. And which item will float? If something is floating, what does that mean? If an object is floating, for example, this wooden cork is floating, what does that mean? That upthrust is greater. Upthrust, the force which is acting in the upward direction is so much larger that it is not letting this wooden cork sink, and the downward force is lesser, right? It has a lighter mass, right? That's why. This happens because of difference in their densities. Because density is your mass upon volume, right? Okay. So density. The density of a substance is defined as mass upon volume. And there is a symbol which we give to density. We denote it either by D or by rho. Both are the symbols of density. The density of cork is less than density of water. If density of cork is less, what does that mean? If density of cork is less, it means it will float. What does that mean? That its upthrust, the upward force which is acting on this cork is greater. Correct? The upthrust of water on the cork is greater, right? That's what I told you. Then the weight of the cork, so it floats. And now let's see the case of the iron nail. The density of an iron nail is more than the density of water, which means that the upthrust of water is less. So what happens in the case of nail? It sinks down. It sinks down. Why so? Because the downward force is greater, simply. And your upward force is lesser, right? Your upthrust of water is less than the weight of the nail. That's why it sinks. Okay. So some common examples of different densities. So let's see some things which have different densities. So objects of density less than that of liquid float on the liquid, right? Of course, we just saw if they have lesser density means more upthrust. If something has lesser density, that means the upward force which will be acting on it will be more, because your lesser density means lesser mass means lesser weight means that your downward force is less and your upthrust is greater. So in this case, the object will in density less float. And if your density is greater, then your object will sink. Greater density means that your upthrust is lesser and your weight is greater, right? So a piece of ice floats on water whereas stone sinks in water. You need to tell me that ice has greater density or stone. Of course, your ice has lesser density, right? Lesser density. So it has more upthrust of liquid, right? And your stone has greater density. Of course, stone has greater mass and greater density, and so it sinks. Oil floats on water, whereas lime juice mixes with water. Why does oil float on water? What does that mean? That density of oil is less. Density of oil is less than density of water. Whereas lime juice mixes. If lime juice is mixing with water, what does that mean? That both have same density. So they mix. Okay. So density and its unit. The unit of density is kilogram per meter, kg per meter cube. Okay, how do we derive it? We know density is equals to mass upon volume. What is the SI unit of mass? It's kg. What is the SI unit of volume? Meter cube. Kg per meter cube is your SI unit. The density of a given substance under the specified condition remains the same. Therefore, the density of a substance is one of its characteristic properties. The density of a given sample of a substance can help to determine its purity. So let's do this question. Why is it difficult to hold a school bag having a strap made of a thin and strong string? So if you have thin string, think about this. If you have a thin strap in your school bag, what will happen? It has a lesser area. And lesser area means we know that pressure is equals to force upon area. Pressure is inversely proportional to area, and lesser area means more pressure. And what does more pressure mean? More pressure means more burden on your shoulders, right? So it is difficult to hold a school bag having a thin strap because the pressure on the shoulders is quite large. This is because the pressure is inversely proportional to the surface area on which the force acts. The smaller the surface area, the larger will be the pressure, right? In case of a thin strap, the contact surface area is very small. Hence, the pressure exerted on the shoulder is very large. Simply, pressure is force upon area. More the area, less the pressure, right? And lesser the area, more the pressure, right? So let's do question 2. What do you mean by buoyancy? The upward force exerted by a liquid, right? For buoyancy was your upward force. We have talked about buoyancy a lot in this part, right? A lot. So the upward force exerted by a liquid on an object immersed in it is known as buoyancy. When you try to immerse an object in water, then you can feel an upward force exerted on the object, which increases as you push the object deeper into the water. So why does an object float or sink when placed on the surface of the water? Because of density. Density is your mass upon volume. Correct. So if your density is less than that of water, if you have placed an object in water, if the density of object is less than density of water, then what does that mean? Then more upthrust will act on it. What does that mean? It will float. If your density of object is greater than density of water, then what will happen? If the density of object is greater, then your upthrust is lesser, right? What does that mean? That your object will sink. Correct. So let's do an activity with a stone. So we took a stone, we tied it with a thread, and firstly we just held it with our hand in air, and then we held it in our hand in water. And what is the result? What did we observe? That the elongation produced in the string or the spring balance is due to the weight of the stone. Since the extension decreases once the stone is lowered in water, it means that some forces act on the stone in the upward direction. Of course, in this case, when you put the stone in water, there is one force which is acting on it, and you will tell me its name. Its name is buoyancy. Right, that is your upward force is acting on this, right? And when in air, there is no buoyancy, no buoyant force, no upward force acting, right? As a result, the net force on the spring decreases and hence the elongation decreases in water. Okay. So, Archimedes' principle. The upward force exerted by water is known as force of buoyancy. It helped him to determine the purity of the gold in the crown made for the king. So, yeah, this story which I was, discussing earlier, that bathtub story. So, this person, Archimedes, who gave the Archimedes principle, he started, shouting in the bathroom, Eureka, Eureka, when he discovered this principle of water, okay? So, because it helped him to determine the purity of the gold in the crown made for the king. So, why was he shouting Eureka, Eureka? Now he'll be getting some reward. King will be giving him some reward because, he can check the purity of gold in his crown, right? And this concept which he gave, of the displaced water, the concept which Sir Archimedes gave is very useful, right? So, Archimedes' principle, what does it state? When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of fluid displaced by it. Right, so we discussed it while we were discussing some previous examples, right? So let's get ahead. Applications of Archimedes' principle. It is used in designing ships and submarines. Lactometers, which are used to determine the purity of sample of milk. Archimedes' principle is used in it also. Hydrometers. So Archimedes' principle has application in hydrometers also, which is used for determining density of liquids. Okay. So let's do this question. You find your mass to be 42 kg on a weighing machine. Is your mass more or less than 42 kg? So, on a weighing machine, you are actually not seeing your weight, you're seeing your mass. Your weighing machines are calibrated. What does calibrated means? Calibrated means it doesn't take gravity into account. Okay. So, of course, your mass is definitely more than 42 kgs. Okay. Your weight is definitely more. If your mass is, 42 kg on weighing machine. So, you have a bag of cotton and an iron bar, which each indicating a mass of 100 kg when measured on a weighing machine. In reality, one is heavier than other. Can you say which one is heavier? So, when you will just read it, you will find that, oh, iron bar is heavier because cotton is so soft and but no, this is not the case. What is the case? That the bag of cotton is heavier than the bag of iron. Why? Because cotton bag experiences a larger air thrust than iron bar. Therefore, the weighing machine indicates less weight than its actual weight for the cotton bag. The reason is your true weight. What is your true weight? True weight is your original weight, is your apparent weight. Apparent weight is the calibrated weight which your weighing machine is showing plus upthrust. Upthrust is your upward force, right? Acting on it. Buoyant force. Upthrust is a buoyant force. So, this is your true weight, right? True weight. The cotton bag's density is less than that of iron bar. So, the volume of cotton bag is more compared to the iron bar, right? Density is mass upon volume. So, the cotton bag experiences more upthrust due to the presence of air. Therefore, in the presence of air, the cotton bag's true weight is more compared to the true weight of iron bar. So, remember this true weight is apparent weight plus upthrust. So, relative density. Relative, as the term suggests, relative means in relation to something, right? So, relative density we compare with respect to water. For example, I am asking you what is the relative density of, let's say, copper. So, it is your density of copper upon density of water. So, we are comparing the density with respect to water. So, relative density is the ratio of its density to that of water, right? Relative density of a substance is ratio of the density of substance to the ratio of the density of water. Since the relative density is a ratio of similar quantities, it has no unit, okay? Of course, relative density means density upon density. So, what is the unit of density? What was your unit? Newton per meter cube. And here also Newton per meter cube. Everything cancels out. So, relative density has no unit. Which quantity has no unit? Relative density. Okay. If your relative density is greater than 1, what will happen? Your object will sink. Why so? Because if your relative density is greater than 1, what does that mean? That means your density of substance is greater than density of water. That's why your relative density is greater than 1, right? And if your relative density is less than 1, then your object sinks. Why so? Because your density of substance is less than density of water in this case. So let's do this question. Relative density of silver is 10.8. Density of water is 10 to the power 3 kg per meter cube. Right, density is unit. What is the density of silver? We know relative density is what? Density of silver upon density of water. Density of substance upon density of water, right? So here our substance is silver. So relative density is density of silver upon density of water. So density of silver is relative density of silver into density of water. And we are given relative density of silver and density of water. We can calculate the density of silver in SI units by just plugging it in the formula. So this is how we calculate it. So let's do a quick revision. So the law of gravitation states that the force of attraction between any two objects is proportional to the product of their masses, right? And inversely proportional to the distance between them, right? This law applies to objects anywhere in the universe. Such a law is said to be universal. So this is known as universal law of gravitation. This is when we initiated the chapter. This was the initial thing, right? Gravitation is a weak force. Okay, this is very important. Gravitation is a weak force unless large masses are involved. The force of gravity decreases with altitude. What does that mean? As your height decreases, your G decreases. Okay. As your height increases, your G also increases. It also varies on the surface of Earth, decreasing from poles to equator. So, your force is minimum on equator and maximum on poles, okay, because your G decreases with altitude. So when your altitude increases on your pole, you have a greater altitude, right? So you have greater force. The weight of the body is the force with which the earth attracts it. Weight is equal to the product of mass and acceleration due to gravity. Weight is equals to m into G. So revision, the weight may vary from place to place, but the mass stays constant, right? All the objects, so weight variable because it depends on G. Mass constant because it is independent of G, correct? All objects experience a force of buoyancy. Buoyancy was your upward force. And what was its other name? Upthrust. All the objects experience a force of buoyancy when they are immersed in fluid. Objects having density less than that of liquid in which they are immersed float on the surface of the liquid, right? If the density of the object is more than the density of liquid in which it is immersed, then it will sink in the liquid. So, this is the end of the chapter and I hope you all have understood it. And thank you very much and bye-bye.